Let's begin 12.4 matrix algebra. This starts out with just talking about a matrix is a rectangular array of numbers. And we'd like to be able to find the sum and the difference of two matrices. First of all, let's make one 1, 2, 3, 4, 5, 6. This is a matrix that has 2 rows and 3 columns. We call it a 2 by 3 matrix. 2 rows, 3 columns. In order to add or subtract, two matrices have to be what they call conformable. For addition and subtraction of matrices, conformable means the same size, a 2 by 3. This is the dimensions. So let's call this 7, 8, 9, 10, 11, 12. We can add and subtract these two because they are conformable. They are the same size. Their answer will be a 2 by 3. So to find the sum of two matrices, you add the corresponding elements. 1 and 7 is 8. 2 and 8 is 10. 3 and 9 is 11. 4 and 10 is 14. 5 and 11 is 16. 6 and 12 is 18. Man, gee, I noticed here. 3 and 9 is not 11, it's 12. So 8, 10, 12, 14, 16, 18. I guess that's what I expected. That is the answer. That is what these two matrices. Now we usually use uppercase letters for matrices. So A plus B is equal to, we'll call this, I guess, C. And you could put that in your calculator, but addition and subtraction is pretty easy for these matrices. Let me do a subtraction problem. Let's take a 1, 2, 3, 4. This is a square matrix. It's a 2 by 2. And subtract 5, 6, 7, 8. Which of course is what the dancers always say right before they start dancing. So 1 minus 5, this equals also conformable because they're the same size, 2 by 2, 2 by 2. It gives you a 2 by 2 as an answer. 1 minus 5 is a negative 4. 2 minus 6 is a negative 4. 3 minus 7 is a negative 4. 4 minus 8 is a negative 4. So, subtraction, addition, not so bad. Matrix algebra also includes not just addition and subtraction, but multiplication. There are two types of multiplication. One is called scalar multiplication, and the other is matrix multiplication. So, for scalar multiplication, you can take any matrix. Let's do a 3 by 2. So that means 3 rows. 1, 2, 3, oops, by 2. 1, 2, 3, 4, 5, 6. And if we multiply that by a scalar, and that's really what it does, it scales things up or down. Let's multiply by 2. This just multiplies every single element. If you start with a 3 by 2, you'll end with a 3 by 2. It'll just be scaled up. In this case, it will be doubled. So this is a 2 and a 4 and a 6 and an 8 and a 10 and a 12. So scalar multiplication is just multiplying every single element in the matrix by a real number, non-zero. But there is matrix multiplication. This may not be able to see that very good. Matrix multiplication. Now, what is conformable for matrix multiplication? Well, in order to multiply two matrices, let's suppose one is an m by n, like a 3 by 2, m by n. And if we want to multiply another matrix by it, these inner dimensions must be the same. It must be an n by something else. Let's call it k. This is what makes multiplication, matrix multiplication, conformable. The outer dimensions is what your answer is going to be, which can help you in determining how to do this. So, if we take, say, a 3 by 2, and we'll do the 1, 2, 3, 4, 5, and 6. 3 rows, 2 columns. In order to do matrix multiplication, the next one's got to be a 2 by something. Let's do a 2 by 2. And let's do, I don't know, let's 1, 2, 3, 4, just because. Your answer will be a 3 by 2, the outer dimensions. Now what does that mean? I guess there will be 3 rows and 2 columns. So you know what your answer is going to look like. A 3 by 2 times a 2 by 2 is going to produce a 3 by 2. So how do you multiply matrices? It's important here to recognize what this dimension for your answer really means. You're going to take this 3 by 2 and you're going to fill in this first row, first column entry. This is first row, first column. And in order to get that, you use the first row and the first column. 1 times 1 plus 2 times 3. To get the first row, second column, I'm going to have to expand this a bit. We need to use the first row and the second column. So it's 1 times 2 plus 2 times 4. Not this 2, that 2 times this 4. Does that make sense? To find the second row, first column, use the second row and the first column. 3 times 1 plus 4 times 3. And then for the second row, second column, use the second row and the second column. 3 times 2 plus 4 times 4. To find the entry for the third row, first column, use the third row, the first column. 5 times 1 plus 6 times 3. And to find the entry for the third row, second column, use the third row and the second column. 5 times 2 plus 6 times 4. And that's matrix multiplication. Of course, you should find your final answer. So together, those are going to be, let's see here. So this is 1 plus 6, or 7. This is 2 plus 8, or 10. 3 plus 12 is 15. 6 plus 16 is 22. 5 plus 18. 5 and 18 is 23, right? And 10 and 24 is 34. This is a 3 by 2. So, matrix algebra, multiplication, scalar multiplication, matrix multiplication must be conformable for this to work. If the inner dimensions are not the same, you don't do anything, can't do anything.